In this video, I'm going to show you how I fitted this thing onto this thing. Not too long ago, when I was doing my 10 days 10 tips videos, go watch them if you haven't, around day 4 I think it was, my extruder just gave in. This is a very, very, very common problem on the Ender 3. In fact, it's a common problem on any of the Creality 3D printers that have this model of plastic extruder. In fact, this is not the first time I've had to deal with poor extruder durability with plastic extruders. Here is my Monoprice Mini Delta with a replacement piece on the outlet end of the extruder. This happened to both my Mini Deltas, so I'm quite used to extruders breaking on me. You can actually print out the arm for this too, just like you can with the Monoprice ones, and I might give it a go at some point to see how durable that fix is, because that sounds quite interesting to do, but you could also buy them. This one is one I bought here ages ago in anticipation of at least one of my Enders breaking. This part costs about £3.50 I think, that'd be about $5. It's worth having a spare one around, assuming that you don't fit a metal one like this. What do these cost, about £15, £12 maybe? I do have mixed feelings about these kits because there can be some really poor quality ones, and it's a lot of time to change it over to fit it and then realise that it's not good quality. Anyway, all that said, I polled you guys at the time on the community polls, and you told me that you'd rather see me do a video on upgrading this machine to a direct drive. And yes, that means that everything I just said is not going to happen, at least at the moment. So let's do that instead. This is the kit that you received from Creality. I bought it from Banggood, and I'll show you my receipt. £28 and 5p. And this is what we call a cracking price, because it includes an entire hot end assembly, an entire extruder assembly, including the motor. Okay, the extruder's still plastic, not brilliant. It includes the frame and the wheels, and all the wiring. But, of course, this means that this is a really cheap way to get a direct drive printer. I paid £110 for my Ender 3 in a random sale on the website here. That is about £20 lower than the going rate at the moment, but I managed it, so potentially that's possible. This means that I've paid a total of £140, which is about $185, for all of this, which will be a direct drive printer. Plus, I guess about £15 for the magnetic bed if you want to count that as well. I'm not sure if you can get direct drive printers for that kind of money, but even though the Ender 3 has its issues, it really is quite a workhorse. So I think it would be very difficult to beat that price for what you're going to get if you fit this kit, if it works. Let's find out. So you get a couple of tools in here. This spanner is useful, so keep that, but for the rest it's probably better to have your own screwdriver set, and you need hexagonal bits. I'm not sure if this is supposed to be a manual, but it's of minimal use, especially since I don't even have this version of the board. So first up is to remove the screws to get at the motherboard, noting that there's one long screw at the back and two at the front. This is obviously for the standard Ender 3 model. The V2 should support this mod. I think it's still 24 volts. But the board is in a different place, you just have to get to it differently. And the same with the Pro. My Ender 3 came with a 32-bit board, which is what they've been doing for probably about the last year, I think. This, in reality, is not an upgrade over the 8-bit board that they were originally shipped with, because it's still got the noisy drivers on it, there's no silent drivers, and the stock firmware for the 32-bit boards doesn't add any functionality. In fact, it takes it away. Believe it or not, this version of the firmware ignores filament change commands, which is really useful, and it ignores stop commands. But more on that later, because I have a silent board ready to fit in an upcoming video, which will be fun. So the general idea with fitting this mod is to remove the current hot end assembly from the bar and remove the corresponding wires from the board, and replace it all with the new wires and the new assembly. While that might sound like a nightmare, it's actually not that bad, because this is all one wiring loom, and it's separate from the ones for the board and the servos. And then you use the manual sheet thing that you've got. This allows you to work out which plugs and cables to remove and what the corresponding ones on the new wiring will be. You should probably be aware that these plugs are actually hot melt glued in, or at least they were for me, and that means that you need to get that glue off before you can remove them, which is a bit of a pain, but you can just use a flat blade screwdriver to do that. There's also a couple of troublesome zip ties involved, and you have to be super careful not to accidentally cut open the wire insulation like I did. Luckily, I only did it on the ones I'm removing, so it doesn't matter so much. The next logical step would be to take this cable out completely that you've just removed the wires for, the one that goes to the old hot end assembly, which I'm not doing, as I might want to undo this mod for demonstration purposes in the future, so I'm just tucking it out of the way. What would be needed if you did want to remove it would be to take off the horrible black tape that they've put on the cable where it enters the casing. It's hard to see it, but there's some tape there. You can also leave it in place if you think you might want to swap back, or even if you're just a bit lazy. I don't see what harm it will do to leave it there as long as it's out of the way and it's not going to touch anything by accident. I'm going to stop here and show you something important, which I might make a full video about because it's a massive thing that you probably need to know, but I don't think it's really widely known. The wires that these printers come with, at least the heating elements, are what's known as tinned, meaning they've put solder on the end to kind of hold the stranded wire together. This is fine in most hobby electronics situations, but for the hot end wiring, and especially the heated bed wires, it is apparently absolutely not okay. I've seen multiple reports of incidents where, through presumably thermal expansion and contraction and wires becoming loose in those terminals, or maybe some other mechanism, you end up with burned connectors where they screw into the terminal. So the solution is to use one of these. This tool is a crimp tool, and it's made specifically for this kind of ferrules here. These literally just go over the wires and they crimp on. Now, importantly, I am not an electrician. I am probably not doing this optimally. I'm probably not doing it right at all, so please do not follow my advice on how to do this. Instead, I will link below to some actual electricians who will show you how to do it properly. It goes without saying that doing this wrong could also cause a dangerous electrical fault, possibly even more than the original one, especially on the heated bed wires, as there's around 10 amps in those wires, which is capable of fairly catastrophic failure. I don't want to scare you into thinking that this kind of failure is common. I haven't seen it on any of my printers, but you should definitely be aware that if you ever get a weird smell or smoke coming out of the printer, it is probably time to have a look and check for this problem. Back to the modification. With everything in place, it's just a case of making sure the new wires are routed sensibly and putting everything back to the routing it was at before. You could probably spend more time on this than I did. It's quite hard with the cameras in the way, and I know I'm ripping all this out in a couple of weeks. That's my excuse, and I'm sticking to it. Remember to plug the fan back in, and remember to plug the screen back in, and then put the case back on. The next bit, there's two ways to do this. You need to get the print head off the rail and put the new one back on. And even after removing the tensioner on the end, you'd think you'd be able to slide the head off, but actually no, it hits the triangular piece behind. Now, I found it relatively easy, if a bit annoying, to remove the two screws that go from the triangular piece into the bar, and then you can move the triangular piece out of the way, and then you could just roll the head off and put the new one back on. I understand that you can also loosen the lower pulley wheel on the carriage of the new assembly. Which you choose to do is up to you. I don't think there's any advantage to either way. Tightening up the belt after you've put it on and hooked it up is even more important now, because the extra weight on this assembly will need less slack in the belt. Make sure your belt is also not touching the sharp part of the aluminium profile as you see here. I find that tilting the tensioner slightly downwards will achieve this, otherwise it's in contact and it's scraping and it will shorten the life of your belt. You'll almost certainly need to adjust the eccentric wheel on the new hot end assembly, the one that you may or may not have just loosened to get it on and off. It's underneath, and you could use the spanner provided. You're looking to remove any wobble at all. There should not be any back and forth wobble, but you also don't want to feel any bumps as you move the carriage across the x-axis. Any bump sensations that you can feel when you're doing that means you have the wheels set too tight, and you need to loosen them off. Believe it or not, you also get marks on your print if you have this too tight. Obviously now the extruder is going to be moving around with the hot end, the filament path is completely different. The simple fix appears to be to turn the filament reel holder just 180 degrees so it's facing forwards and put it in the centre. It seems like a pretty obvious fix, and it appears to work, and that's good because it means you don't have to put any extra effort or buy anything else to do that. If your filament reel is already kept off to one side of the printer, then good luck with that. With all that done, I fired up the printer, I tested every axis using the menus, I heated up the hot end and tested the extruder, and it all was working. But we have forgotten one thing. I almost sent a test print at this point, but I managed to cancel it at last minute, and I'm really glad. What have I forgotten? Of course, I've forgotten to re-level the bed. This is an entirely new assembly, so the chance of the nozzle being in the same place is nearly zero. However, the chance of breaking something by forgetting to level the bed is definitely not zero. That was easy enough. Once the bed was levelled, I did a test print of this train here. It came out really well, and I'm very pleased with the results. I also wanted to check for any artifacts due to the extra weight, so I tried the Aperture Science weighted companion cube, which should show any serious issues up in the same way that a normal calibration cube should. All was well, except from some missing bits, if you could see here on the close-up. This did initially worry me. I mean, it could be temperature issues or under extrusion due to something like poor E-steps calibration. E-steps calibration is the ratio, in case you didn't know, it's the ratio between the extruder's movement and how much filament you want to extrude. So changing the size of the gear on the extruder is one cause of needing to recalibrate E-steps. So let's sum up. Would I recommend you performing this upgrade? Actually, sure, why not? It would have taken about an hour if I wasn't filming it at the same time, so it's a pretty quick process. It doesn't contain any steps that are particularly difficult. In fact, the chances are you've already built the printer once yourself, so it's no harder than that. The only tips I have are about the wiring and making sure everything is calibrated properly. The whole thing comes pre-assembled and the E-steps seem to be the same, so it's really well thought out. I know you will all probably want to know how this thing works with TPU. After all, that's the main driver for changing to a direct drive usually. That, though, is for next time. Well, maybe the time after next, because I've got a 2-colour GEEEE tech printer in the hall that's waiting for me to build, and I can't wait to do that. Which does remind me, if anyone knows or has tips on how you create a 2-colour G-code from presumably 2-colour STL or 3MF files, then I would like to talk to you, because this is uncharted territory for me. As usual, any comments or questions, please put them below. I have a few announcements to make when I can figure out what to say or how, but it's just about things I want to do or am doing and about the future of the channel. For now, I will mention that I've started a Patreon, so that's linked below. I've created a Discord. The intention with the Discord is that we can share pictures and more information than's possible in the comments, which is really helpful from a diagnostic point of view. I have people asking questions that myself or other people could answer, and sometimes it would be useful to be able to provide more information than you can in the YouTube comments. You get the idea. I don't know if it will be of any use. I don't know if it will go anywhere, but I'm willing to give it a go anyway. The link to that is also below. Otherwise, I'll see you next time. Thank you for watching.